In this video, I'm going to show you guys how to find the derivative of a trigonometric function using product rule. But before I start, I actually want to show you guys some basic differential rules, or let me say differential identity when it comes to differentiation of trigonometric function. Now, suppose we are given y equals what? Sine x, right? We are given y equals sine x and we are asked to find the y by the x, and that's going to be y prime. Whenever you differentiate sine x, it's going to give us what? Cos x, right? Then if you are given y equals what? Cos x, right? And you're asked to find the derivative of cos x, this is going to give us y prime is going to be equal to minus sine x, right? So this y prime in this case represents the y by the x. So let's say you are given y equals to cosec x, right? And you are asked to find the y by the x of what? Of cosec x. So that's going to be equal, y prime is going to be negative cosec x, right? Cot x, cosec x, cot x. That's basically what we are going to have. So x should be here, cosec x, cot x. Now suppose we are given y equals to cot x, right? And we are asked to find what? The y prime. That is divided by the x of cot x. Whenever we differentiate cot x, we are going to have it to be negative cosec squared x. That's what we are going to have it to be. Then let's say we are given y equals to sec x, right? And we are asked to find what? The y prime of sec x. So whenever we are asked to find the y prime of sec x, this is going to give us basically sec x and tan x. Sec x tan x. That's basically what we are going to have. So this actually the differentiation of trigonometric function that we actually have. And the other one that we can have is actually whenever we are given y equals to what? Tan x, and we are asked to find the derivative of tan x, is going to give us what? Y prime, which is the derivative of what? Tan x, and that's going to be sec squared x. That's what we're going to have it to be. Now, if you look at this very well, these functions, whenever we are dealing with trigonometric function, right, using product rule, we want to find the derivative of trigonometric function using product rule. All these identity, or let me say all these differential formulas, you have to know them. That is whenever you are given y equals to sine x, the derivative of sine x is going to give us cos x. The derivative of cos x is going to give us minus sine x, right? Then let's just go ahead and solve some questions under this product rule with trigonometric function. Now let's start. Now let's take a look at the first question I'm having here. We are given y equals to let's just say f of x equals to x squared sine x. So this expression is actually the same thing as writing y equals what? Uv, right? So in that case, I'm going to take my x exactly. Now, if I go ahead and find the derivative of u with respect to x, that's basically du dx, right? Du dx in this case is giving what? 2x. And then here I'm going to have dx. Du dx in this case is going to give you what? If I differentiate sine x, don't forget I'm going to have to what? Cos x, right? Now in that case, I can just read the formula using the formula of a product, and that's clean. Whenever I'm having y equals to uv, right, as in this case, I'm going to have it to be what? To be the y by what? By the x, right, equals to what? I'm going to have it to be v du dx, right, v dx, then plus u dv dx. That's what I'm going to have it to be. Now if from that case, look at this v, the value of v, this implies that the v is actually what? Sine x, right? V is actually sine x according to this diagram here. Then from there we have what? Du dx. Du dx actually what? 2x. That's what I'm going to have what? Multiply by what? 2x. Then plus here we're going to have u. The u is actually what? We're going to have to be x squared by what? Our dv dx. Dv dx here in this case is actually what? Cos x, right? I'm going to have to what? Cos x. Now if I simplify further, I have the answer to be dy by what? By the x is going to be equal 2x sine x, right? Then plus you have to what? S squared cos. So that's basically what the answer. Now let's go ahead and solve another question. Now if you look at this question, we are given y equals to s squared cot x. That's what we are asked to find, the derivative of what? Of y. So from here, what I'm going to do is that I'm going to take my u to be equal to what? S squared. I'm going to take my v to be equal cot x. ensure that I can, if I'm finding what the derivative of both u and v, I'm going to have my du by what, by dx to be equal to x, and at the same time I'm going to have my dv by dx to be equal, whenever I differentiate what x, I'm going to have it what to be, that's minus cosec squared x minus cosec squared x. That's the derivative, right? So what I'm going to go ahead and do now in this case is actually what to differentiating y equals to uv. We're going to have our product root to be divided by what, by the x, equals to what, u. That's going to what, x squared multiply what, dv dx, which is what, minus cosec squared x, right? Then plus again, I'm going to have v, which is actually what x, right? Then multiply what, du dx, that's actually what, 2x. So we're going to go ahead and simplify from that. I'm going to have divided by what, by the x, equal, we're going to have, here is going to be 2x cos x, right? Then we're going to have minus s squared cosec squared x. That's what we're going to have, and this is going to be the final answer. If you like, can just go ahead and factorize s here, or if you like, can just leave the answer like this. So that's just it. So let's go ahead and solve one more question. Now, if you take a look at this question that I'm having here, we are given y equals to x to the power of 3 cos x. And in that case, that basically means I can just record the formula for the product, because everything here is actually a product. We are having a polynomial function multiplying with a trigonometric function. So in that case, if I recall, the y bar was by the x, right, is going to be equal v du dx, right, v du dx, then plus u dv dx, right? That's what I'm going to have. That's basically what I'm going to have it to be. Then from here, divided by the x, and here, if you look at this, my v, I'm going to take my v to be equal cos x, right? Then I'm going to take my u to be equal to what? X is power of what? Of 3. Then from there, I can actually find du dx. Du dx here simply means I'm going to find the derivative of what? Of u, and that's going to give me 3s squared, right? Then going ahead to find what derivative of what? Of v, I'm going to have dv dx to be equal, differentiating cos x, I'm going to have it to be sin x, right? So when I go ahead and put all these parameters into the formula, let's see what I'm going to have. I'm going to have it to be basically here, we're going to have it to be divided by what? By the x, divided by the x is going to be equal v, that's actually what? Cos x, then multiply what? Du dx, du dx is actually what? 3s squared, right? Then plus again, I'm going to have v as u rather is going to be what? S raised to the power of 3. Then we're going to have multiply by what? Dv dx in this case is actually what? Sine x. So we're going to go ahead and simplify this experiment a little bit. I'm going to have this what? 3s squared plus x, right? Then I'm going to have plus x is power of 3 sine x. I can actually go ahead and choose to simplify further again, or I can leave the answer like this. If I'm going to simplify further, I'm having x is power of 2 here, and I can actually factorize it out, and in that case I'm going to have x squared, right, into brackets. I'm going to have this what? 3 cos x, right, then plus what? X sine x. That's what I'm going to have it to be, and this is going to be the final answer. Everything here is equals to what? Divided by what? Divided by the x. Now let's go ahead and solve another question, right? Now let's take a look at this question. If you look at this very well, we have the constant value here multiplying to trigonometric function. So I go ahead and take my u to be equals to 2 sine x and my v to be equals to cos x. Let's see what we're going to have. If I find the derivative of what? Of sine x, or let me say, if I differentiate 2 sine x, I'm going to have it to what? To be du by what? By the x, and it's going to give me what? Just ordinary. We're going to hold our 2, right? Then we differentiate what? Sine x. If we differentiate sine x, we're going to have what? Cos x, right? Plus when we hold our what? Sine x, and we differentiate what? Our 2, which is going to be what? 0. So everything we're going to have here is going to be du by the x, which is what? 2 cos x. That's what we're going to have. Now for the v, if whenever we differentiate what? V or cos x, that's going to be dv dx, and dv dx is going to give me minus sine x. Whenever we find the derivative of cos x, that's what? Minus sine x. Now if we go ahead and put it inside the product formula, we're going to have what? We are going to have dy by what? By the x equals to what? Equals to u in this case is going to be 2 sine x, right? Then multiply what? Dv dx, that's going to be what? Dv dx is going to be minus sine x again, then plus our b is going to be what? Cos x, right? Then multiply what? Du dx. That's going to be what? 2 cos x. So from here, if I simplify a little bit, we're going to have this to be equal. We're going to have minus 2 sine squared x minus 2 sine squared what? X plus what? 2 cos squared x. That's what we're going to have. Now, if you go ahead and simplify this expression further, because we cannot just drop the answer here. Now, if you look at this, if you notice, we have minus here, right? And then again, if you look at this zero, we have plus a, right? And then we can factorize 2 out. We're going to have what? We're going to have 2, right? Open bracket. We're going to have this what? Minus sine squared x, right? Then we're going to have plus what? Cos squared x. So that's the answer, right? Or we simply write this vice versa. Cos squared x. This is our final answer for what? So this one, when we solve it